indicates that you are active. We're about to start this live class now. This indicates that you are active tonight. All right, so tonight we shall be looking at integration of exponential function. In our last class, we have discussed other forms of integration. We have seen integration of various forms. So today our emphasis will be on integration of exponential function. All right. At the end of this class, you should be able to understand the concept exponential function, integrate exponential function correctly, apply the general integration formula, and solve questions, standard questions, or examination standard problem. All right, so what is an exponential function? I will just give a brief definition, then we proceed into what we have for today. When you hear the word exponential function, it's a function in which the variable appear in the exponent. It's a function in which the variable appears in the exponent. Okay. If we have a function like this, y equals exponential x, y equals to e to the power of 2x. If I have y equals to e to the power of 5x plus 6. All of these are exponential functions. So it's a function in which the variable appears in the exponent. The variable appears in the exponent. So I mean the variable here are representing powers. The word exponent simply means powers, right? Okay. All right, so we're going to look at general form of integrating an exponential function. And I give us a table of differentiation that if I have y as a function and I have change in y over change in x, all right? If we are to differentiate ax to the power of n, the result will give us nax to the power of n minus 1. This is the power rule of differentiation. If we are to differentiate exponential x, we're going to have exponential x. If we are to differentiate exponential kx, the result becomes k exponential kx. Right? If we are to differentiate sine x, the result is cos x. If we are to differentiate cos x, the result is sine minus sine x minus sine x. If we are to differentiate tan x, the result is sec square x. If you are to differentiate ln x or log x, the result is 1 over x. Then we say that integration is the reverse process of differentiation, meaning if we integrate this to give us this. If we integrate this, it will give us this. The integral of exponential x is same as what? Exponential x. The integral of this will give us this. Integrating cos x, the result is sin x. Integrating sin x, the result is minus cos x. Because differentiating cos x will always give us minus sin x is a rule. So the reverse process becomes integration of sin x will give us minus cos x. Integrating sec square x will give us tan x. When you integrate 1 over x, the result is what? Ln x. So, and we have talked about some of this in our previous class. If today is your first time in joining us, make sure you go to the first class on integration, second on integration, the third on integration. So, we'll look at the first rule of exponential function. The first rule of exponential function. Okay, let's look at case 1 or the first rule. The first rule of exponential function. The rule says that integral of exponential function dx is equals to exponential function plus what? Plus c. That's what the rule is saying, which is this rule here. meaning that if we are to integrate exponential x, the result becomes what? Exponential x. But don't forget that differentiation always eliminates constant terms, right? So when you integrate a function, we have to add back the constant term that was eliminated from differentiation. So that means anytime we integrate a function, we have to add what? To a c to it. All right, so please take note of that. Now, let's look at some examples. Example, if we have to evaluate the following, Number one, we have we have evaluate integral of 7 exponential x dx. Number 2, integral of 10 exponential x dx. Number 3, integral of minus 3 exponential x dx. Okay, from what we have here, the rule says anytime we integrate exponential x, it remains the same as what? Exponential x. Then we're going to add 7 to it. So to integrate this, don't forget that we have a constant term here. I have to factor out this constant term, then bring out the integral sign. We have our exponential x dot what? Dx. So when we integrate this, look at it here. This is exactly what we have here, right? So that means the result becomes 7 times exponential x plus what? Plus c. 7 exponential x plus c. That will be the result. So for this, I will also factor out this 10. We have here as 10 integral of exponential x dot what? Dx. This becomes what? 10, okay? Integrating exponential x will give us what? Exponential x, then plus what? Plus c. This other one will give us, here we have a constant term here, which is minus 3. Minus 3 integral of exponential x dot what? Dx. So by the time we integrate this, that will give us minus 3 exponential x plus what? Plus c. So this is how we integrate exponential. And this is the first case, or the first condition, or the first rule under integration of exponential function. Please, if you have joined this class, make sure you just like the class, then share. All right, so let's proceed. Now we have seen the first rule of integration of exponential function. Let's look at the second case. The second case under exponential function. Second case under exponential function. The case says that if we have an integral of exponential ax plus b dot dx, all right, this becomes 1 over a exponential ax plus b plus c. This is what the case is saying. This is what it's saying here. Or better way of putting this is that if we have an integral of exponential f of x, all right, integral of exponential f of x dot dx, this becomes all right, 1 over f prime of x, 1 over f prime of x exponential the original function plus what? Plus c. Please take note. If I have integral of exponential f of x, where f of x is a function, okay, of x, all in the x, This becomes what? 1 over f prime of x, exponential f of x plus c. But f of x must be a linear function, all right? Must be a linear function of this kind. Okay, but we'll solve some problems to see how we can differentiate different forms of this expression. This is similar to this. Here we have I equals to integral of exponential as plus b dx, meaning 1 over a. How do you get 1 over a? A is the differential value of this. When you differentiate as plus b, that will give us what? A. Then they will say repeat backwards the function. Okay, so this is the second rule. So let's solve some problems here. If we have this, let's solve a problem here. Let's solve some problem. If we have to evaluate exponential 2s plus 4 dot dx. Solution to this from the rule of integrating exponential function of this kind, we say that integral of exponential ax plus b is equals to 1 over a, right? 1 over a exponential as plus b, then plus our constant, right? Plus constant. This is what we're going to have here. That means this whole expression, our I, being an integral of exponential 2x plus 4 dx will be 1 over, in this case, when we compare this with this, our a is actually 2, right? So here become 1 over 2 exponential as plus b is same as 2x plus 4. Then the rule says plus what? Plus c. Okay, let me show us alternative way. Alternative way, we can also solve this, which is the main way. Anyway, which is the main way. The alternative way we can solve this is that don't forget we say that anytime we differentiate exponential x, the result is exponential x. If we differentiate exponential u, it's still exponential what? U. If I differentiate exponential k, it's still exponential what? K, right? So what we do here is that I will look for a means to express 2s plus 4 to be in this form. If we differentiate this, rather, we have this. We have this, right? Then the integration is not the reverse, meaning if I'm to integrate this, I'll fall back to this. Integration of EU will give us what? EU. EK will give us what? EK. It's a reverse process. So what we do is that I have to look for a means to express the whole of this to be in this form. So I can say let u equals to 2x plus 4. Let's call this equation 1. So my integral becomes integral of exponential u dot dx. Let's call this equation what? 2. All right, so what do we do here? I have to differentiate u with respect to s, right? In order to generate dx, because the authority or the right to integrate EU is not the s, but rather the u. So I'll look for a means to eliminate the s by bringing in our du. And to generate the u, or to bring in the u, I have to differentiate u with respect to x. So that will give us du over dx equals to 2. So the next is to cross multiply this. By the time we cross multiply, the u times 1 is the u equals to 2 times the s is 2 dx. What do we have to do? What do we do to get the x? I have to make my dx a subject of the formula by dividing both sides by 2. Dividing both sides by 2. So here becomes du over 2 equals to what? Dx. Meaning our dx is equals to du over what? 2. Let's call this equation 3. So what do we do next? Now we have gotten our dx. I can put my dx here. By the time we put the s here, the s will be replaced with what? Du over 2. Right? That means we are bringing in the u, right? Because we have u here. I can't differentiate this. Please take note. So I can integrate this rather. Take note that if we have exponential u dot dx, this can never be equal to exponential u plus c. It's not possible because the authority to integrate eu is not the s but rather the u. So that's why we have to differentiate this to bring in that du. Are we there? And we have achieved that. So let's substitute our du, our dx as du over 2 in equation what? 3. I'm going to say put equation 3 into equation what? 2. So that will give us our integral I equals integral of exponential u dot our dx. Our dx is du over 2. Here we have du over 2. So here we have half. We have 1 over 2. I can factor out the half. Here we have I equals to 1 over 2 integral of e to the eu or e to the power of u dot du. Now we can now integrate because the right to integrate eu is du. Before now we have the x. I can't integrate here because I have the x. The x and u are not corresponding, but u and du are corresponding. So I can integrate this. But don't forget that the integral of eu du will give us eu plus c. So here becomes I equals to half eu plus what? Plus c. So here we have our integral equals to 1 over 2 e. Our u is 2s plus 4. So we have 2x plus 4. Then plus what? C. Please take note of this. Take note of this. Now let's solve more examples. Please, if you're active, if you're online, indicate that you're online. Okay. Another example. Here we are asked to evaluate our integral of exponential 5x dx. In as much as we have a single term here, does not mean the answer will be exponential 5x plus c. This is wrong. Yeah, I have a linear function. Don't forget. And I say that integration of exponential function that has a linear function ax plus b will be 1 over what? A exponential ax plus what? B. Or if I have an integration of exponential x, all right, x, this will give us what? Exponential what? X plus what? Plus c. Okay, so let's look at this here. Here we have a variable here, a linear function, and the coefficient of this x is 5. So this is not like this. Are you there, somebody? So here we have exponential 5x dx. So I have to treat this as a linear function by treating 5s as u. All right. So I will use this same rule with this rule here. This same rule here can also be applied here because the coefficient of this x is what? Is 1. So this is more like saying 1 over 1, right? 1 over 1 exponential x plus c. And 1 over 1 is same as 1. 1 times es is still ex. Are you there? So that is why I have to just explain to just describe this for you guys to understand. Now, if I have 5x, I'm going to say let, this is not the answer. I'll say let u equals to what? 5x. So that my du, our du, okay, if u is 5x, integral becomes integral of exponential u dot what? The x, right? U dot the x. So the next is to differentiate u with respect to x, which is equals to 5. When we differentiate u with respect to s, we have 5. So yeah, I'm going to cross multiply this. That will give us du equals to 5 dx, right? 5 dx. So by the time we differentiate, we can make our dx a subject of the formula. That means our dx will give us du over 5. Okay, this is our equation 1. This is our equation 2. This is our equation 3. So I can say put equation 3 into equation 1, right? Into equation 2 rather. And 2 says I is equals to integral of EU dot dx. So our integral becomes integral of EU dot our dx is du over 5. Du over 5. So that will give us our I equals to integral of, 1 over 5 rather. Integral of e or exponential u dot du. So the right to integrate e to the power of u has been generated, which is what? Du. So we can apply the first case, right? On the integrand, yeah, this is the integrand. So let's apply it here. We have I equals 1 over 5 exponential u plus c. So our I becomes 1 over 5 exponential or e to the power of u. Our u is 5x. So we have 5x, we have plus c. Okay, let's see another example. Another example. Another example we have here says integrates, evaluates integral of exponential minus 4x dots dx. Definitely this will give us, if we are to solve this, this will give us differentiating minus 4x give us minus 4. So here will give us 1 over minus 1 over what? 4 exponential minus 4x plus c. This should be the answer, right? But let's verify. Yeah, we're going to say let u equals to minus 4x. Minus 4x, right? So that means our integral, this is equation 1. Our integral becomes integral of e minus, eu dot what? Dx. Then I will differentiate this. We have du over the x equals to minus 4. From here, we can make we can cross multiply, right? Just to make our ds a subject of the formula. And that will give us our du equals to 4 dx. So from here, by the time we divide both sides by 4, dx becomes what? Du over 4. Du over 4. Sorry, minus. Okay, minus, right? Minus, right? Minus 4 times the x is minus 4 dx. So here we have minus du over 4. So I can call this equation 3, and I will say put equation 3 into equation 2. Okay, so equation 2 actually states that this is our equation 1, this is equation 2, right? Meaning I'm going to put my dx into this expression, right? That will give us our integral. Let's recall that integral equals to integral of exponential u dot what? Dx. This is the equation 2, which is this, right? So let's put our dx. That will give us I equals to integral of EU dot our dx is minus du over 4 minus du over 4. So here, we factor out minus 1 over 4 integral of exponential u dot what? Du. And that will give us I equals to minus 1 over 4 exponential u plus what? C. So the final answer becomes our integral equals to minus 1 over 4 exponential, our u is minus 4x. So minus 4x, then plus c. This is the final answer here. So let's look at more example. More example. Today our emphasis will be on exponential function. All right, so that we can maximize this today. Then tomorrow or next, we'll look at integration by parts. The next question says that evaluate exponential minus 2x minus 2x minus 1 dx. Okay, we can apply the same rule here that says that the second rule of integrating exponential function that says that integral of exponential function of f of x dot dx is equals to 1 over f prime of x exponential f of x, right? F prime of x exponential f of x, meaning I will differentiate this. By the time we differentiate it, that will give us minus 2. So we have minus 1 over 2 or 1 over minus 2 exponential this. So the answer is meant to be the result using this rule. That will give us our integral equals exponential, minus 1 over 2 exponential minus 2x minus 1 plus c. This should be the result, right? But let's verify and see. We're going to say let u equals to minus 2x minus 1, equation 1. Then it means that our integral becomes integral of exponential, u dot what? Dx. This is equation 2. Then we have to differentiate this. We have du over what? Du over dx will give us minus 2. Therefore, that implies that our du is equal to minus 2 dx, right? By the time we cross multiply this, minus 2 times dx is minus 2 dx equal to du. Then we have to make our dx a subject of the formula. So that means our dx will give us our du over what? Over minus 2. Which is also same as minus du over 2. This is our equation 3. Then we say put. Okay, let me take off this. Put equation 2 into equation 3. Put equation 3 rather into equation 2. Meaning I'm putting this, I'm putting the value of my dx as minus du over 2 into equation 2 that says that our I equals to integral of exponential u dot dx, right? And that will give us our integral equals exponential, our u is minus 2x minus 1 minus 2x minus 1, right? Minus 1, okay? That's our u. All right, sorry. Our EU dot, our dx is minus du over 2 minus du over 2, which can be factorized. And here we are going to have minus 1 over 2 integral of exponential u dot what? Du. So now we have the right of integration, and that will give us our I equals to minus half exponential u plus c. plus c. Then we can put the value of our u as minus 2x minus 1. That will then give us the final answer. It's still the same thing. Okay, so let's see another example. Like I said, this class will not be long. I will not spend much time here. Let's look at this different integration. Please, if you are following, indicate in the comment section. And once you join, please like the class. Click on the like button. Click on the like button. It helps in this. It helps us in visibility. All right. Please, let's click on the like button. Let's click on the like button. If you're active, indicate in the comment section. If you're active, indicate in the comment section. If you're active, indicate in the comment section. We have a question that says evaluate integral of, this is question 1. Then our integral becomes integral of 3e. Our 4x is, we represent u as 4x. So here we have u dot dx. So here we differentiate u. The u will give us what here? 4dx. Right? The u will give us 4dx. The u dx is equals to 4. So by the time we cross multiply, that will give us the u equals to what? 4dx. Right? So we have this. So this is the u equals 4dx. So I can then make our dx as subject. That will give us our dx equals to what? The u over 4. This is equation 1, equation 2, equation 3. Then I will say put equation 3 into equation 2, and that will give us what? That will give us integral I equals integral of 3e. All right. U dot our dx is the u over 4. We have the u over 4. So here I have two constants here. This is like saying 3 over 1. So 3 over 1 times 1 over 4 will give us I equals to 3 over 4 integral of exponential u dot what? Du. So by the time we integrate this, that will give us our integral equals 3 over 4 exponential or EU plus C. So our integral becomes 3 over 4 E. Our U is equal to 4x plus C. Final answer with this. So let's look at the next question. Please, if you are following, indicate in the comment section that you are following. If you are following, indicate in the comment section. Okay, next question. We are moving towards advanced question. Gradually. We are moving towards advanced question. Gradually. The next question here says integrate or evaluate integral of 4 exponential 2x minus 3x. 2x minus 3x. All right. 2x minus 3x. So what do we do here? This is all in the x. What do we do here? We have to the same process again. Okay, that will give us let's say let's u equals to 2x minus 3x. Is that 2x minus 3x? I'm sorry. 2 minus 3x. Sorry, 2 minus 3x. 2 minus 3x, right? So here we have let u equals to 2 minus 3x. All right. So our du will be minus 3 dx. By now we should know how we got this, right? When you differentiate u with respect to x, du over dx will give us minus 3. So by the time we cross multiply, du times 1 is du, minus 3 times dx is minus 3 dx, which is what I have here. So I can make my dx a subject of the formula, and that will give us our dx equals to du divided by minus 3. Or we can say minus du, right, over 3. Now what do we do next? This is our equation. Okay, this is our equation 1. Okay. Okay, I will have just generate equation 2, but the procedures are still accurate. But let us generate equation 2. If u equals to this, that implies that our I equals to integral of 4e u dot what? Dot dx. Then we can say that the du equals to differentiating du with respect to s will give us du equals to minus 3 dx from what I just expressed now. Okay, so here we have this as equation 2. So let's go. Here becomes our dx equals to what? Du divided by minus 3, or minus du over what here? 3. This is equation what? 3. We know what to do now. We have to put equation 3 into equation 2. That says that I equals to what? We are putting equation 3 into equation 2. So that means our I equals to integral of 4 eu dot dx, right? And that will give us, okay, it will give us our integral of, okay, integral of 4 eu dot our dx is minus du over 3 minus du over 3. So this is also same as minus 4 over 3 integral of eu dot what? Du. Eu dot du, right? So our final answer here becomes our integral of minus 4 over 3 exponential, or eu, plus what? Plus c. So our I equals minus 4 over 3 e to the power of u. Our u is 2 minus 3x. 2 minus 3x, then plus what? C. Please take note of this. Take note of that. Please, if you are following, indicate in the comment section. If you are following, indicate in the comment section that you are following. Please indicate that you are following in the comment section. If you are following, please indicate in the comment section. If you are following, indicate in the comment section. All right, so let's see more example. Let's see more example. All right. Here we are asked to evaluate integral of s cubed exponential x to the power of 4 dot dx. Okay. Integral of s cubed exponential x to the power of 4 dot dx. You know, yesterday we learned use substitution, direct substitution, called U what? Substitution, right? Substitution, is that not? Now we have to represent exponential s to the power of 4 as u. Then differentiate it. That will give us what? 4s cubed. Then s cubed, we cancel s cubed. Then we can integrate further. The reason why we have to make this as u is because we need to cancel out this. Because by the time we introduce the u, we cannot integrate because we have x. Is that not? And by the time we select u equals to this, I can't still integrate because I have what? This x here. Okay, so what we have to do is to apply the u what? Substitution. Okay, solution here says, to solve this, solution here says let u equals to x to the power of 4. Let's call this equation 1. If u equals to s to the power of 4, that will give us our integral equals integral of x to the power of 3 e to the power of u dot dx. The next is to differentiate the u with respect to s just to get what? Our dx, like we have been doing so far. So we say du dx, or du rather, du will be equals to 4x to the power of 3 dx. By now we know how we got this. From here, du dx du over dx is equals to 4x to the power of 3. So by the time we cross multiply this, the u times 1 is du. Du equals to what? Du equals to 4x to the power of 3 dx, which is what I just stated here. Then I can make my ds as subject. So we have our dx is equals to du divided by 4s cubed. This is equation what? 3. So we can go ahead and substitute. This is our equation 2. This is equation 3. I can say put equation 3 into equation 2, meaning I'm going to substitute the value of my dx into this so that s cubed can cancel what? S cubed. So we have our integral I equals to integral of s cubed exponential u dot our dx is du over 4s cubed du over 4s cubed. So from here, this can go with this. Sorry, this is 4s cubed. S cubed can go with what? S cubed. So we are left with integral I equals to integral of eu dot du over 4, which is I equals to 1 over 4 integral of eu dot what? Du. So the right to integrate this is du. So this will give us our I equals to 1 over 4. Integrating this will give us au, then plus what? C. So final answer becomes I equals 1 over 4. E, our u is actually s to the power of 4, x to the power of 4, and plus what? C. Final answer. So I can put this on. Okay. Next question. Please, if you are following, indicate in the comment section that you are following. Please indicate. Once you join, please ensure you like the button. Just like the video for more visibility. All right, so let's solve this question we have here. Here we have to evaluate integral of exponential x, exponential power x dot square roots of 1 minus exponential x dx. Okay, so let's look at this together. We are going to use our U substitution, the same thing we just did in the previous example. I will make my U equals to this so that when we differentiate this, I will still maintain it, then this can cancel out with this. Exactly. Then we can have our dx. Okay, let's see what will be the result. Yeah, I want to say let U equals to 1 minus E x, right? So our dx, our du rather, our du will give us, when you differentiate, okay, let me bring it at du dx. When you differentiate 1, we have 0, so this is already off. When you differentiate exponential x, the result remains minus exponential what? X. Don't forget, differentiating e to the power of x is still e to the power of x. So here we have minus sign, right? So that implies that our du will give us minus ex dot what? Dx. Is that clear? Minus ex dx. So let's take note. Minus ex dx. So here we have this as okay, I will have just said, I'm sorry. Let me repeat this again. This is our equation 1, right? Then our integral I becomes integral of exponential what? X dot root u. Is that clear? Root u dot what? Dx. So we already know that our du is minus exponential x dx. Like I differentiated u with respect to x, that will give us minus ex, then dx. Like I say, du over dx. In differentiating 1 is 0, so we have 0 minus differentiating ex remains ex. So we have here as minus ex. By the time we cross multiply this becomes du equals to minus ex dot what? Dx, right? Minus ex dot dx. So let's go. This is equation 2. All right, so this, let's make our dx a subject. Okay, a subject. So we have our dx will give us, okay, minus du over exponential x. All right. Well, by the time we divide both sides by minus exponential x, that will give us minus du over what? Exponential x. Hope we are following. So this is equation 3. I can say put equation 3 into equation 2, and that will give us equation 2 actually states that our I equals to integral of exponential x, okay, exponential x dot root u dot dx. So that will give us I equals to integral of exponential x dot root u dot, our dx is minus du over exponential x minus du over what? Exponential what? X. So this can go with this because we don't need x to integrate this, because the right to integrate this is du. So we have our integral I will be, here we have minus sign, right? We have minus integral of root u dot du. Root u dot du. Of course, yes. Root u dot du. So we already know that this expression is also same as minus root u is u to the power of 1 over 2 dot what? Du. 1 over 2, meaning u to the power of half is same as root square root of what? Of u, or in what? All in du. So we can integrate this expression with respect to du, and that will give us minus u to the power of 1 over 2 plus 1. Here I'm going to use a power rule of integration. The power rule of integration will land here. So it says if I have x to the power of n dot dx, so this will give us x to the power of n plus 1 over n plus 1, then plus c. Is that clear? So, yeah, I will use the power rule to integrate this expression here. And the power rule says I will add 1 to this power and divide by the resulting power. So, this will give us, okay, our integral equals to minus, right? Okay, integrating this, here we have, okay, this rather, u to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1, then plus c, right? Okay, we already know that 1 over 2 plus 1 is 3 over 2. 1 over 2, let's check this out, is 3 over 2. So let's see, half plus 1 over 1. The LCM here is 2. It's 2. 2 into 2 is 1. 1 times 1 is 1. Plus 2 into 1 is 2. 2 times 1 is 2. So 1 plus 2 will give us 3 over 2. So here we will have here as our integral I equals to minus u to the power of 3 over 2. Okay, divided by 3 over 2 plus c. We are not done. Let's evaluate. Let's finalize the answer. Please take note of all of this. Let's finish up. Let's finish up what we have. So by the time we evaluate this further, this will be our integral I equals to minus u to the power of 3 over 2. This is a division sign, so I can say divided by 3 over 2, right? Plus what? Plus c. So our integral becomes, our integration becomes minus u 3 over 2 times 2 over what? 3 so, plus c. So this will give us our I equals to minus u 3 over 2, sorry, minus u 3 over 2 times 2 will give us minus 2. Minus 2u 3 over 2, right? Divided by what? 3 plus 4c. Final answer becomes I equals to minus 2 u. Our u is 1. Our u is 1 minus exponential x, right? To the power of 3 over 2. All divided by what? 3 plus what? Plus c. This is the value here. Okay. I would have loved to show us the reverse process of this. When you differentiate this, the result will fall back to this, because differentiation is the reverse process of integration. Integration is also what? The reverse process of differentiation. All right, so let's look at another example. Please, if you are following, indicate in the comment section that you are following. And if you join us, make sure you click on the like button. Ensure you click on the like button. Ensure you click on the like button. Okay. Next question. Next question. Question says, evaluate integral of exponential x plus exponential minus x, all divided by exponential x minus exponential minus x, all in what? Dx. Evaluate this. I'm going to stop here for tonight on integration of exponential function. I'll stop here tonight, okay, so that we can rest. Then tomorrow we continue with other form of integration. We have other form. There's a last case I would have loved to show us, but I want us to pause here for now. Okay, then tomorrow we continue. But this is your assignment. This is your assignment. Please take note of this. Let me add another question that will launch us in tomorrow's class. Integrate the following: 5 exponential x dot dx. Okay. Number 3, integrate 10 exponential 2x plus 4 dot dx. Okay. Number 4, integrate 3 exponential 4x plus 5 dot dx. So these are your assignments. Someone will say, why am I giving us this kind of question to solve? Why are we having that kind of expression to solve there? Okay, please take note of this. Let me give a quick hint on this, like I can solve this, then I will see how I can touch one or two here. Just a quick hint. What I need to do here is this. Look at this expression here. You know, this is just like saying, I give you a rule yesterday, a form that said integral of du, right? Du over u, is that not? Which is integral of f prime of x over what? F of x, or du over u. That means I will make my denominator equals to u. I will say let u equals to e exponential x minus exponential what? Minus x. Then I will differentiate this. By the time you differentiate, you get a value that will be equal with this. Then you can cancel out from there. Then integrate the entire expression. Please, if you can solve this in the comment section, please indicate in the comment section. If you can solve this in the comment section, please indicate in the comment section. Please indicate now in the comment section. Please indicate if you can solve this in the comment section. If you can solve this in the comment section, please indicate in the comment section. I said what we need to do here is a very simple case. We're going to say let u equals to exponential x minus exponential minus x. Is that not? Okay. If u equals to this, that will give us, that means our integral I equals to integral of exponential x plus exponential minus x. Is that not? Divided by what? By u dot what? Dx. Okay. Okay. X. This is our equation 1. This is our equation 2. All right. So I'm already tempted to solve this, but let me finish up this. So here we have du over what? The x will give us. I will differentiate this, right? And this. Differentiating this remains, it remains exponential x. Is that not? Then yeah, differentiating exponential minus x will give us plus exponential what? Minus x. I hope it's clear. If I'm to differentiate only this expression, just this alone, okay, I will come back to this question. Let me just take a snap. I'm coming. Sorry, guys. Okay. Let me just solve this question so that we can be on the same pace. I might not have time to come back here tomorrow to solve it. Maybe tomorrow we'll just go into another form of integration, right? Yeah, we are giving this to solve integral of this. I'm sorry, let me just solve this for us so we can take notes. We say let u equals to this, right? Here we have minus sign here, I guess. Okay, minus sign. Okay, u equals exponential x minus exponential minus x. Is that not? Minus x. So here becomes, our I becomes integral of exponential x plus exponential minus x divided by exponential x sorry, divided by u, right? Dot what? Dx. This is equation 1. This is equation 2. So I will differentiate this. I will say du over dx, right? We give us, differentiate this, I have exponential x. If I'm to differentiate y equals to exponential minus x, the rule says differentiate this, right? We have minus 1 over 1, right? Exponential minus x. And that will give us what? Minus exponential what? Minus x. So if I'm to differentiate this alone, I'm going to have minus exponential minus s. The minus times minus will then give us plus. So when you differentiate this alone, the result will give us minus e minus x. And that will give us plus, right? Plus e minus x. So yeah, I can say that my du is equals to e to the power of x plus e to the power of minus x dot what? Dx. So let's make our dx a subject of the formula. That will give us our dx is equals to du divided by exponential x plus exponential minus x. So let me just round up with this so that we can just continue with other forms of integration tomorrow, because I don't think I would love to come back to exponential function again. I don't think so. So here we have equation 3. We know what to do, right? I will say put equation 3 into equation 2. So equation 2 says I equals to integral of, let's go ahead and put it, exponential x. I'm putting my equation 3. I'm putting the whole of this to replace the x. So we have plus exponential minus x divided by, all right, divided by u here we have here as the x. Our dx is the u. We have here as the x, as which is the u divided by exponential x plus exponential minus x. Now, are you saying that this can go with this because they are the same? So our integral becomes integral of 1, okay, du divided by u, right? I'll give us du divided by what? U, which is also same as integral of 1 over u dot what? Du. Don't forget that integral of 1 over u is ln u. So here will give us I equals to ln u plus c. So our I becomes ln, our u, the value of u is, we say let u equals to this, right? So we have exponential x minus exponential minus x, right? Then plus what? C. This is the final answer to this question. This is the final answer to this question. Okay, then the last 2 questions I stated before I clean the board, let me solve them. I will give the general form, then I will solve. All right. Okay, so please take note of this. This is very simple. Sorry, I have to rush this class tonight so that we can all rest. My target is not to stay beyond 1 hour. But I think we have exhausted almost 1 hour class of our time. All right, we have a question here. The first question I stated here says, evaluate number 1, exponential 5x dot dx. Number 2, exponential 10 to the power of 2x plus 4. Number 3, the third one is already simple. We have already solved something of that kind. The third question, which is integral of exponential 3 exponential 4x plus 5 dot dx. This is already simple, right? We can solve this by now. I think the only question among these questions here that we have not really seen the form is this, right? Now, there is a case I want to show us. We have seen the first, second, and the third case. The third case here, the third case, case 3, says integral of x to the power of, to the power of x dot dx. Integral of a to the power of x dot dx is equals to a to the power of x divided by ln a plus what? C. Please take note of this. Integral of the third case under exponential says that integral of, when I say exponential, does not mean e actually, e to the power. So if I have this, it means that integral of a to the power of x, where x is the exponent, right? Okay, is the exponential function. Here we have a to the power of x dot the x equals to a to the power of x divided by 1 ln a plus what? Plus c. Okay. Now, if we are not giving this to solve, say find 5x dot what? The x. The rule says a to the power of x divided by ln a. Here will be what? 5 to the power of x divided by what? Ln what? Ln 5. Then plus what? Plus c. That is just how to solve this. That is just how to solve this. All right. Okay, I repeat again. Integral of a to the power of x dx equals to what? A to the power of x over 1 ln a. All right. Then plus what? Plus c. So if I have this, it means that here becomes 5 to the power of x over what? Ln 5 plus c. Now let's solve this here. Let's solve this. That means if I have something of this nature, let's say I have integral of, let's say 2 to the power of x dot dx, what would that be? 2 to the power of what? To the power of x divided by what? Ln 2 plus what? Plus 5. Okay, what will happen to this? Listen, guys. The case is this, right? But if I have a function like this that says integral of 10 to the power of 2x plus 4 dot dx dot what? Dx. Look at this here. What I have to do here is to differentiate this. If we differentiate 2x plus 4, we have 2. So that will give us 1 over 2 ln 10 to the power of what? Of this. Let me just show us something. I will just say let u equals to what? 2x plus 4, right? So that means our du give us 2 dx. Is that clear? This is okay, let's say if this is this, so it means that this becomes our integral equals to integral of what? 10 to the power of u dot what? Dx, right? Okay, so I will differentiate this. We have du equals to what? 2 dx. By now we should know how we got du as 2 dx. Differentiating this, we have 2. Then du equals to 2 dx. By the time we cross multiply. So this is our equation 1. This is our equation 2. Let's generate equation 3 by making the s a subject. So the s becomes du over what? 2. This is equation what? 3. So I can say put equation 2 into equation what? Equation 3 rather into equation 2. That will give us our integral equals integral of 10 to the power of u, right? Dot our dx. I'm putting this into this. So my ds is du over 2. So we have du over 2. And that will give us 1 over 2 integral of 10 to the power of u dot what? Du. Are you seeing it now? So what we are doing here is to convert the whole of this to look exactly like this function. Then I can now integrate this. You can see that I've been able to convert this to look exactly. So this and this are now similar to each other. But don't forget that we say that integral of ax, a to the power of x dx is ax divided by ln a. Then that means here will be what? 10u divided by what? Ln u. So if we are to evaluate that further, let's finish up. If we are to evaluate that further, our I will then be half times 10u over ln 10, right? Okay, ln 10. Of course, yeah, we have ax over what? Ln a. So here we have plus what? Plus c. So this will give us our integral r equals to half. Then our u is 2x plus 4. We have 2x plus 4, right? All divided by what here? Ln 10 plus c. A better way to express this becomes, here will give us I equals to what? 10 divided by 2x plus 4 over 2 ln 10, right? Plus what? Plus c. This is the better way to express this. Are we seeing it now? Okay. That is just the final answer to this. So that means we can try the same thing here. If I have this expression, if I have integral of 5 to the power of 4x plus 9 dot dx, the result becomes 1 over 5, right? 1 over 5, 5 to the power of 4x plus 9 divided by what? Ln 5 plus what? Plus c. And that will give us our final answer as I equals to 5 to the power of 4x plus 9 divided by 5 ln 5 plus what? Plus c. I was seeing that it is very simple to solve. Are you there? So if I'm to follow this whole process, I will get the same answer with this. The same answer with this. Okay. I think we are good to go now. We are good to go. We are good to go now. I think I'm going to, I want to find out if there are other questions. Someone asked a question and the person said, so what if I have a quadratic function, e to the power of a quadratic function? What if I have a quadratic function? Let's say we have, find the integral of exponential 2x squared plus 5x plus 6 dot what? The x. What will be the answer to this? The answer to this remains the same. It remains as I equals to exponential 2x squared plus 5x plus 6, then plus what? C. This is it. This is for odd quadratic what? Function. The reason being that, let me explain one or two things. The reason being that even though we are to make this as u, let's say let u equals to 2x squared plus 5x plus 6, plus 6, and you are saying that I becomes integral of exponential u, right? Dot dx. This is equation 1, this is equation 2. So that will give us I equals to, okay, let's differentiate this, right? We said du will give us 4x plus 5. What do you notice here? I'm having a function that cannot cancel out here. I can't cancel out this function. If I'm to make my dx, this is 4x plus 5 dx, right? Plus 5 dx. Let's make our dx a subject. That will give us what here? Du over 4x plus 5. So by the time we put this back, let's see. This is equation 3. By the time we put this back in equation 2, we'll have I equals to exponential eu dot our dx is du over 4x plus 5. Is that clear? So here we have our I equals to, okay, are you saying the fact that I can't continue with this because I have a function with respect to x here and I have du here? There's no term that can cancel out from here. So that means that the integration of every quadratic function remains the same. it remains the same, just like we see. But if the question comes in this form, let me give a form. The question comes in this form, okay? The question comes in this form. I want us to get one or two things tonight. Majority of you will appreciate this class because some of you will keep on doing calculus in your year 2, year 3 till you finish your university, especially those in engineering department. If the question comes this way, that we should integrate 4x plus 5. 4x plus 5 exponential 2x squared plus 5x plus 6 dot dx. This is very, very much possible. This is not same as integral of exponential 2x squared plus 4x plus 5 dot dx. It's not same as that, right? Because here I can differentiate this. If you differentiate this to give us this function, then I can cancel out. So this is more accurate than this. So if you are giving this in the exam, two things are involved. It's either there's an omission of this function, or the lecturer doesn't want to test your intelligence to know if you know what you are doing. Are you there, somebody? So the answer remains the same for this. But for this solution to this, we're going to say let u equals to what? 2x squared plus 5x plus 6. So that means our du will give us 4x plus 5. 4x plus what? 5. So yeah, all in the x, right? Okay, let me say this, bring it out again. Our I equals to integral of, we have 4x plus 5 eu dot what? The x. So I will differentiate this. We have the u equals to what? 4x plus 5 times what? The x. By now, you know how we got this, right? Okay, so yeah, our dx will give us our du over 4x plus what? 5. 4x plus 5. 4x plus 5. 4x plus 5. That's our du, our dx. So this is equation 1, equation 2, equation what? 3. So I'm going to put equation 3 into equation what? 2. That will give us our I equals to integral of, we have 4x plus 5 times e to the power of u. Our dx is du over 4x plus 5. Are you seeing it now? That this expression, we go with this expression. So we are left with I equals to integral of eu dot du. eu dot du. And that will give us our integral equals eu plus what? Plus c. So our I becomes e. Our u is 2x squared plus 5x. 2x squared plus 5x plus 6. Then plus what? C. That's the final answer. I will pause here for now. Then we'll meet again in our next class. My name remains EMI-BRAIN. EMI-BRAIN. If you need private coaching or want to ask questions, you can always DM me on this WhatsApp number. This is a WhatsApp number. This is my WhatsApp number, okay? You can always reach out to us if you have any further question. So I will stop here for tonight. Ensure you go through the classes again. This is a complete package under integration of exponential function. Then my next class will look at integration by parts. Integration by part, then I will give you the rule, okay? The rule used in solving or in evaluating any function that have to deal with integration by parts. We'll look at the priority for choosing u and du and dv. Okay, so don't miss that class. It will be a wonderful class, and everything about integration by part will be dealt with in that class. So please make sure you go to all these classes we have been having. For those of you who just joined us, we have done the first class on integration. We have done the second class. This is the third class. This class on integration will be sectioned into 5. The next class will be by parts. Then the last class will now be by partial fraction, integration by partial fraction. Then anytime we are meeting again, we'll just be on revision on integration and differentiation and their application. Then the last class actually on calculus will be on what we call tangent and normal to a curve, which is a class I would have done before this, but I actually skipped the class. Okay, I will come back to that class. So please ensure you share to your classmates and join us in the next class. Thank you so much, guys. See you in the next class. All right.